Good morning. Happy Monday to you. We're nearly at the end of our little chapter on rational functions and other types of functions. And one of our last topics to talk about are what are called slant asymptotes. These occur when the degree of the numerator is exactly one more than the degree of the denominator. Now remember from the other day, if the degree of the numerator is greater than denominator, then there's no horizontal asymptote. So slant asymptotes don't occur when there's also a horizontal asymptote. They can only occur when there is no horizontal asymptote. And again, they don't occur every time, just if the degree of the numerator is exactly one more than that of the denominator. So how do we find them? So first thing we're going to do is we're going to do some division. We have two choices. We learned earlier this chapter how to do long division, and we also learned how to do synthetic division. Now synthetic division only works if the denominator is in the form x minus c. And I'm going to be nice, and all of them are going to be in that form today. So again, you can use the synthetic division or long division, but synthetic's much quicker. We'll go through a couple examples and remind you how to do that if you've forgotten. So how do I get an answer? Well, anytime again I have this rational function where there's a fraction and there's an x in the denominator, and I do the division either way, my answer is going to end up in a y equals mx plus b format. And then there's going to be a potential remainder. Now that remainder is something we don't really need anyway. We're going to throw it out. And we're just going to keep the mx plus b portion. All right, so let's do a couple of examples. All right, so here I got this one here. Now, in this one, my degree of the numerator is a 2, and my degree of a denominator is a 1. So if we were looking for a horizontal asymptote, we wouldn't get any. But because the degree of the numerator is exactly 1 larger than the degree of the denominator, we're going to get a slant asymptote. And for me, here's how we're going to do it. I'm going to do synthetic division. All right, so for synthetic division, I take the coefficients from my numerator, which has to be in standard form, using any zeros for missing pieces. So my x squared coefficient, my x to the first coefficient, and my constant. Now on the outside of the box, remember that form has to be in the form x minus c. Well, on the outside of the box, I want that c number, which because of that minus sign that's in the formula here, it's always going to be the opposite of what it looks like. So even though it looks like a negative 2 in the formula, as I'm looking right here, I'm going to use the opposite, positive 2. And that's because of that minus in the formula. All right, now when you remember synthetic division, that first number just drops straight down, 1. And now we multiply this number on the outside here, 2, times this number, 1. And when we put the answer in the next column. And then we add that column. Negative 3 plus 2 makes negative 1. And now the same multiply. This 2 times this negative 1, and then we put the answer in the next column. And we add that column. Now that last column's our remainder, and we're throwing it out. We're not going to be using it. Now the other parts are the coefficients in a y equals mx plus b format. In this case, my m is the 1, 1x, and my b is that minus 1. Now if I cleaned it up a little bit, I wouldn't write the times by 1, but now I have an equation of a slant asymptote. If you're wondering what that would look like, they would have an intercept at negative 1 and a slope of 1. So this graph might have things that are curving towards that line as it goes to it. Be an example of what that could look like. All right, let's try one more. All right, I'm going to, again, because the denominator is in that x minus c format, I can do the synthetic division using coefficients from my numerator. Coefficient on the x squared, coefficient on the x, and the constant. And on the outside, I want that c term, which is positive 3, the opposite of what it looks like. It doesn't look like a minus 3, but that's not what it is. All right, now, when I do my synthetic division, first number drops down, and then multiply. 3 times 1. Put it in the next column. And then add that column. Negative 1 plus, or negative 5 plus 3 makes negative 2. Now multiply the 3 and the negative 2. Put it in the next column. And then add them for negative 12. That last piece is the remainder, and we don't need it. The other parts become my slope and my y-intercept. Well, I wrote the wrong letter there. I was thinking slope and wrote the m. I meant the x. And again, just like the last one, we can clean that up a little bit. All right, this is your stuff for today. Good luck.